Okay, so we're on to the last form of solving a linear system of equations, or last style or strategy, I should say. And this is solving a linear system by elimination. And basically what this is we're trying to eliminate one of the variables, so we only have one left, in which case it makes it straightforward and trivial to actually solve for. Now we're going to use a technique that's actually similar to basic arithmetic, where we line up the columns. In this case, we're going to line up the columns so all of the same variables are on top of one another, and we'll just be able to either add or subtract to eliminate one of the variables. So let's go through this process. First up, we're going to say we want to solve a linear system by adding or subtracting. That's the big key here, adding or subtracting. We're trying to add or subtract to eliminate a variable. This is called elimination. There we go. And there's a few steps we got to follow. They're similar to what we had before, just a little bit more detailed. First up, as always, we're going to label our equations as 1 and 2. So make sure you have those ones clear. We're going to choose one of the variables. So choose a variable. Oops, we're going to erase that. We're going to choose a variable to eliminate. Doesn't really matter which one, whichever one will seem to be the easiest to work with. And we're going to ensure that the coefficients are the same for both equations. So the numbers in front of the variables, they need to be the same. So when we add or subtract, it's going to eliminate one of them. So if we add a 4x, we'd want a 4x right underneath it. So if I subtracted them, 4x minus 4x makes it go away. So if the coefficients are not the same, what we're going to do is we're going to multiply either one or both of the equations by some value so that they will have the same coefficient in front of the variable to be eliminated. So the idea is kind of similar, like we're trying to find like a common coefficient. Not quite unlike finding the lowest common denominator when we're working with fractions. We're trying to find a common coefficient so we can eliminate one of them. So the next step is to subtract if the coefficients are the same sign. So for example, if I had a 4x and a 4x, I want to do 4x minus 4x, and that'll make it 0x, which would make it go away. So if they're the same sign, then I want to subtract. However, I want to add if they are opposite signs. So for example, if I had a 4x and a negative 4x, 4x plus negative 4x gives me 0. So that's the idea. So we want to subtract if the signs are the same, add if the signs are opposite. Then once we do that, we're going to break it down and we're going to substitute our solution back into one of the original equations to find the value. So now we're back to similar to what we were doing with substitution before. So we're going to try and find the value of the second variable. Then of course we're going to check our solution with a left side, right side check, just like before, if the question asks us to, or if we feel, generally speaking, the need to do so. So let's scroll down a little bit here and let's try this out. So I want to solve this linear system by elimination, and we want to check our solution. So we're going to have to do a left side, right side check on this one. So first thing, we got to label our equation. So that's going to be equation 1, and this one is going to be equation 2. So we have 2x plus y equals 8 and 4x minus y equals 8. Now the y's already have the same coefficient, so I don't have to do any fancy multiplying or anything like that. I just need to decide whether I should add or subtract. Now these y's, the coefficients on them, which is just a 1 on both y's, they have opposite signs. So that means I want to add. 1 plus negative 1 gives me 0. So I'm going to draw a little arithmetic line here, and I want to add these two. So as we did before with substitution, we want to kind of write out every single step so we know what's going on when we do so. So I'm going to say I want to do 1 plus 2 here. Okay? So 2x plus 4x, that gives me 6x. Plus 1y minus 1y, that gives me 0y, so I don't have to write anything. 8 plus 4, that gives me 12. This is a nice easy one. Divide both sides by 6, and we have x is equal to 2. Now we're back into familiar territory. It's just a matter of taking this value, substituting it back into either one of the original equations to find the other values. So let's bring it back. We're going to say sub x into, let's say, 1. And our goal is to find y. Okay. So now we have, wherever we see an x, we're going to put a 2. So we have 2 times 2 plus y equals 8. So we have 4 plus y is equal to 8. Bring the y, or 4 over to the other side, and we end up with y is equal to 4. So we've found our solution, so we can say, therefore, the point of intersection is 2, 4. Great. But this question specifically asks us to check our solutions. That means we have to do a left side, right side check on both equations. So let's say check 1, and we'll do check 2 over here. Oops. There we go. Check 2. So we have left side, and we have right side. Over here we have left side, and we have right side. Okay. On the left side over here, we have 2 times 2 plus our y, which is just 4. And on the right side, we have 8. So 2 times 2, that's 4, plus 4. 4 plus 4 is 8. So 8 is equal to 8. Great. So the left side is equal to the right side. No weirdness going on here. On the other one, we have 4 times 2 minus y, which is 4. And on the right-hand side, we have 4. So 4 times 2, that's 8 minus 4. 8 minus 4 is 4. And again, they match. So we have left side is equal to right side. That's all there is to it. So we just got to, let's try one that's a little bit more complicated this time. This one's going to take us a little bit of work. But we don't have to check our solutions, so we're just going to go for it. So on the bottom here, we have solve the linear system by elimination. We don't have any nice values for matching coefficients, so we're going to have to do some work. Step number 1, label our equations. So this is going to be equation 1, and this one's going to be equation 2. Okay. So first up, our goal is to get matching coefficients. There's no easy one here. However, what we're going to do is let's try and get the x's to match. So what is a common multiple that I can get to here? Well, if I get them both to 12, 8 won't work because that's multiplying 4 by 2 will get me to 8, but I can't get 3 to 8. That doesn't work. But they do have a common multiple will get us to 12. So in this case, if I take the first, or let's do the second equation first. So we're going to take this guy, and we're going to multiply it by 3. The entire equation by 3. So this is going to be 4x times 3, so that's going to be 12x, minus 3y times 3 is going to give me 9y, and minus 13 times 3 is negative 39. We're going to call this equation 3. Now the next one, equation 1, to get it to 12, we have to multiply it by 4. All right, so this is going to be equation 4 when we're all said and done. So 3x times 4 is going to give us 12x. Good, we have a matching coefficient now. 5 times 4, that's going to give us positive 20y. And we have 12 times 4, which is going to give us 48, not 44. 48. Now we have to look at these two and say, all right, are we going to add or subtract? Well, they're the same sign, so we're going to subtract. So it's going to be 3 minus 4. Okay. So 12 minus 12, they just go away. Negative 9 minus 20. That gives us negative 29y. And we have negative 39 minus 48. That's going to give us negative 87. Now, when we divide that, those actually divide nicely, believe it or not. That's actually going to come out to y is equal to 3. 29 times 3 will give you 87. Awesome. So we found a solution for y, but now we need to find the associated x component. So we're going to take this value, and we're going to sub our y into our easiest equation for us. I don't know. Let's just use 1, I guess, because they're both not that friendly. And our goal is to find x this time. That is an x, I swear it is. Okay. So wherever we see a y, we're going to put a 3. So we have 3x plus 5 times 3 equals 12. So we have 3x plus 15 is equal to 12. So 3x, and the 15 goes over the other side. So we have 12 minus 15, which is going to give us negative 3. Oh, this looks nice. So we divide both sides by 3, and we know what x is equal to, negative 1. So, therefore, the point of intersection is x of negative 1 and a y of 3. Now, this question didn't ask us to do a left side, right side check. Feel free to if you'd like to, but it's not required at this moment. So that's probably about as complicated as it's going to get, with the exception of sometimes you're going to run into ones with like fractions and things like that. That's just the nature of the beast. So let's go on and let's go over to the next question. Now, this one is just adding another level, or another step, but in the end, it's still going to come out to be the same work. We just have to simplify this first. So we have to distribute these coefficients through, they're coefficients. We got to distribute these values through their brackets, and then we'll work it out from there. So let's start off by labeling our equations. This is going to be equation 1, and this will be equation 2. So let's work with equation 1 over here, we'll work with equation 1 over here, and we'll simplify it. So equation 1, we're going to multiply that through, so we're going to end up with 3x minus 3 times negative 1 gives us 3. And now we go over to the next one. 3 times y minus 3 times y gives us minus 3y. Minus 3 times minus 3 gives us plus 9 equals 0. We're going to collect our like terms and move our constants over to the right-hand side. So that means we have 3x minus 3y. And on the other side, we're going to end up with negative 9 plus 3 is going to give us negative 6. Now we can simplify this further. There's no reason why we can't just divide everything by 3, divide the whole equation by 3, which means we end up with x minus y is equal to negative 2. We're going to call this equation 3. Okay, now let's work with equation number 2. Let's simplify this guy too. So we have 3 times x, which is going to give us 3x. 3 times 2, which is going to give us 6. And we go over to the next piece. Minus 1 times y gives us minus y. Minus 1 times minus 7 gives us positive 7. And it equals 20. So again, we're going to collect our like terms. We end up with 3x minus y. And 6 plus 7, that's 13. 20 minus 13 is going to give us 7. 7. And we can't really reduce this one any further than it actually is, so we're just going to leave it where it is. So this is going to be equation number 4. Now let's look at equation 3 and equation 4. Do we have any similar coefficients? We do. The two y coefficients are the same. They're both 1s, negative 1 specifically. And they both have the same sign. So since they both have the same sign, what are we going to do? We're going to add or subtract. We're going to subtract, right? Okay. So let's look at this. Let's do equation 4 minus equation 3. So we're going to say equation 4 minus equation 3. Okay. So in this case, I have 3x minus y equals 7. And that is going to be over x minus y equals negative 2. And our goal is to subtract these two. 3x minus 1x, that's going to give us 2x. Minus 1 minus a minus. So this is, think of this. This is negative 1 minus negative 1. That's the same thing as saying negative 1 plus 1, which gives us 0. So the y's go away. So we don't have to worry about that. On the other hand side, we have 7 minus negative 2, so that just gives us 9. So we end up with, oops, we forgot our x there. We end up with x is equal to, we got to bring the 2 over to the other side, 9 over 2. Now you might be thinking, Mr. Lane, did we make a mistake? Nope, that's just what it is. Yay. So now that we have a number for that, we can keep going. We need to still get a value for y. So we're going to take this thing and we're going to substitute it in one of the equations. Now we're not going to want to substitute it in equation 1 or 2 because those are not friendly. We're going to substitute it into equation 3 because that's about as simple as it gets. So we're going to say sub x into 3. And our goal is to find y. All right, so we have x, which is 9 over 2. And we're going to subtract from that y. And that's going to be equal to negative 2. So we got to isolate for y. And we got to bring the 2 over to the other side. So we're going to just swap these 2 over to the other side. So this negative 2 is going to become a positive 2. So we end up with 9 over 2 plus 2 is equal to, this negative is going to become a positive on the other side. So this is just a y. Now we can rewrite it the other way, and it doesn't hurt anything to do that because it's a balanced equation. And while we're doing that, we can realize that in order to add these things, we need a common denominator of 2, which means we're going to have to, this is really a 2 over 1, we're going to have to double that. So it's going to be 9 over 2 plus 4 over 2. So we end up with y is equal to 13 over 2. Again, not a pretty number, but that doesn't make it wrong. That's just the way it is. So therefore, in this case, the point of intersection is going to be 9 over 2 for our x, and our y is 13 over 2. Okay, one more left to do. This one has fractions. Now there's a number of ways you can approach this. Depends how confident you are in fractions, I suppose. So looking at these two equations, we got equation 1 here, and we got equation 2 here. Now this says x over 2, but that's the same thing as saying 1/2 x. So those are actually the exact same coefficient. So we can just immediately start working from here. Now some of you might be like, yeah, I know I can, but I really don't want to work with those fractions. So can we do something about that? Sure, we can. We could multiply both both equations by 2, and that would get rid of all of the denominator 2's. Sure, if that's what you want to do, then let's do that. Let's double each equation, okay? So this one down here, equation 3, is going to be 2 times equation 1, and this is going to be equation 3. And then the other one's going to be 2 times equation 2, and that's going to give us equation 4. All right, so let's see this. So 2 times 1/2, that's just 1. So that's just going to give us x. Plus 2 times 1, that gives us 2y, equals 2 times -4, which gives us -8. All right, on the bottom, that 2 goes away. So 2 times 1/2, that gives us 1. So that's just going to be x. And then minus the 2 times this, the 2's are going to cancel out. So we end up with -3y equals 2 times 1, which is just 2. So those are definitely easier to work with if you're more comfortable with that. But the fractions would have worked just fine. You just had to make sure that you're comfortable working with those fractions. So we see that we have matching coefficients for the x. So let's use that. Not only are they matching coefficients, they're also matching signs, which means I have to minus. I have to subtract. So 1 minus 1, it goes away. 2 minus -3 is the same thing as adding 3. So this is going to be 5y. And -8 minus 2 is going to give us -10. So that means y is going to be equal to, divide both sides by 5, we end up with -2. So we have our first component of our point of intersection. So let's substitute it into any equation we want. I'm going to substitute it into equation 3 because I don't want to deal with the other ones. So in this case, we're going to say sub y into 3, and our goal is to find x. Okay, so in this case, we have x plus 2 times our y, which is -2, equals -8. So we have x minus 4 equals -8. So when we bring that -4 over to the other side, we're adding, so we have x is equal to -4. So when all said and done, therefore, the point of intersection is going to be -4 and -2. Awesome. So that's the core of solving by elimination. And that's the first chunk of Unit 1. We'll add more onto it later on. But for now, you know all the basic steps and procedures of solving linear systems of equations. And you should be good to go from here. Good luck. Have fun.